Hello everyone, this is Stefan Chang, one of our academic officers, and today we're going to talk about multivariable functions and partial derivatives. This is going to be an introduction to the EC140 course, which is the math module that you're going to take in your first year, but it's also a revision of what you have studied in high school. Before getting into multivariable functions, let's talk about functions in general. So the old type of functions that you used to see are the ones given like this, f of x equals to x squared, where we have one input, x, and an output, which is given by the one variable. In the case of multivariable functions, we have, as its name suggests, multiple functions. So it can be f of x, y, or f of x, y, and z. In this case, we have multiple variables, and the output are dependent on those variables. So before getting into partial derivatives, let's take a look at the derivative rules that work for the single variable case. So let's start with the constant rule, which says that the derivative of constant is always going to be 0. Then moving on to the power rule, where we have a function in the form of x to the power of n. So for example, x to the power of 8. If we take the derivative of this, this is going to be 8x to the power of 7. Then the product rule, where we have two functions multiplied by each other, we're going to have f prime times by g plus f times by g prime. Moving on to the quotient rule, where we have a function f of x divided by g of x. The derivative of this is going to be f of x prime times by g of x minus f of x times by g prime of x. And all of this we divided by g of x squared. Then finally we have the chain rule, where we have an inside function and an outside function, and the derivative of this is going to be given by this formula here. Let's move on and take a look at an example of partial derivative. We are given a function f of x y, which is equal to 7x to the power of 4 times by y to the power of 3. This is a multivariable function where we have two variables, x and y, and we're asked to find the partial derivative with respect to x and with respect to y. So firstly, we notice that the partial derivative is written in a form that is different from what we are used to see. We have this new symbol here, which del, and this represents the partial derivative, and it tells you that you have to find the partial derivative with respect to x. So this concept of partial derivative is not as complicated as it sounds. All we have to do is to take one of the variable, isolate it, and look at it as if it's a variable. So for example, if we're asked to differentiate with respect to x, we take y as the constant. We can write it like this so that we can isolate it, and then we only differentiate with respect to x. And what we get is this. This part stays constant, and then using the product rule, we get this, which can also be written as this. And then similarly, for the case where we asked to find the partial derivative with respect to y, we just isolate the x variable. So we make the first part stay constant, and using the chain rule, we get this for the second part. And this can be written as this.